Welcome everyone to the live interactive session number 10 of the subject Mechanics of Fiber Reinforced Polymer Composite Structure. Today we are going to discuss some sample problems which will be useful for solving the assignment number 11. Before starting the sample problems, let's revise some of the theory which will be required for solving the assignment number 11. So, till now we only studied the in-plane stresses. In-plane stresses, that is when we consider a plane which has negligible thickness, that is in z direction. There we didn't consider its properties in z direction, considering that each lamina is very thin walled, and we only considered in the direction the stresses and the stresses in the x and y direction, which are called the in plane stresses. But that is not the real case. In reality, when the laminates are stacked, they have a certain thickness, and because of that, there are stress distribution the in all the three directions. Because which we consider as the out of plane stresses. As you can see in your screen, the first, when we consider it in 2D, there are three types of stresses: sigma x, y, and tau x, y. Whereas when we consider it in 3D, that with the removing the assumption of the classical laminate theory that it is has a very thin wall laminate, so we get the out of plane stresses. Now, because of this out of plane stresses between the laminas, there is a problem that there is a failure happens which is called delamination. As in the classical laminate theory, we do not consider the transverse shear stresses and also the stress boundary conditions. But when we consider those assumptions, we can find the out of plane stress values, and they will be useful to understand how delamination between different laminates can occur. Now, to find the values of the out of plane stresses, we first consider the stress equilibrium equations, and from the stress equilibrium equations, for assuming the stress is independent of the x, we get the out of plane stresses at the free edges, which is the stress boundary condition of a lamina. When so we as you can see here from the here on the screen, that sigma z, tau xz, and tau yz are the out of plane stresses, which is actually the shear stress in xz direction, the stress in xz direction, the shear stress in xz and zx direction, which will be symmetric, so their value will be equal, and the shear stress in yz and zy direction, which will also be equal because of symmetry. And to find those values, we need to find those values. We have to consider we have to find the values of the in-plane stresses, which we already know how to find from the classical laminate theory. So here you can see the shear stresses in xz and yz direction are the shear stress in xz direction is dependent on the shear stress in xy direction, whereas the shear stress in yz direction is dependent on the stress in y direction, and the stress in z direction is dependent also on the stress in y direction, and all these values are what is responsible to study the delamination of the lamina. Now let's move to the questions. So question number 1: in a plus 45 degree and minus 45 degree symmetric graphite epoxy laminate, so we have to find the value of its Poisson ratio. Now, whenever a laminate comes, the first thing we consider is its ABBD matrix. As here it is symmetric, so the B matrix will be 0, and there is no curvature, so D matrix will also be 0. So only we have to consider the A matrix. Now from A matrix we can find the mid-plane strains, and from mid-plane strains we can find the global strain of the whole laminate. Now from global strains we have to change it to the material axis strains. For that we have to multiply it with the transforming matrix. Here you can see the transforming matrix, which is used to change the global to material axis. But for a 45 degree angle, the plus and minus 45 degree angle, for both the transforming matrix value is same. As the transforming matrix value will be same, Hello, Mritha. Narayan. Hello. Okay, I actually started the presentation and I'm right now discussing the first question. Okay. So here you can see as the transforming matrix will be equal for both plus and minus 45-degree angle. So the strain values will also be equal for both plus and minus 45-degree angle laminas. And if the strain values are same, so the ratio, the Poisson ratio, which is the ratio between transverse and longitudinal strain, will also be equal. So hence we will get the answer as the option 1, that is the Poisson ratio in X will be equal for both the laminas. Next question is, in a plus 45-degree and minus 45-degree symmetric graphite epoxy laminate, what will be the relation between the shear extension coupling? As you can see, for a plus minus theta symmetric laminate, this is the values we get, that is the stress in x direction for plus and minus will be not equal to 0 and will be equal, whereas in y direction it will be equal to 0, and the shear stress in for the plus and minus theta laminates, it will be equal but opposite to each other, that is one of them will be positive, for positive theta it will be positive and for the negative theta it will be negative. So because the shear stress values are opposite and equal to each other, so the shear extension coupling matrix will also be such that it will be equal and opposite in sign. So from that we can get that the shear extension coupling value for the positive 45-degree will be equal and negative of that of minus 45-degree angle. So from the options you can see only option which defines this condition is the second one, that they are not equal. As they are not equal, but their values are equal but opposite in their signs. Next question is, in a 0 and 90-degree symmetric graphite epoxy laminate, what will be the value of the Poisson ratio? Now, to define this, I took an example from the last sample problem discussion session, and here the values are given of the Q matrix, and from that we get the A matrix, and we finally find the material axis strain in a 0-degree ply and the 90-degree ply. As you can see, by comparing the strains of 0-degree and 90-degree, you can see the strain in x direction of 0-degree is equal to the strain of 90-degree ply in y direction, whereas the strain in y direction of 0-degree ply is equal to the strain in x direction of the 90-degree ply, which means that the strain values of the 0 and 90-degree in x direction is not equal. And to find the Poisson ratio, we have to find the ratio of the transverse to longitudinal strain. So the value of the Poisson ratio will be different for the 0-degree and 90-degree plies. Hence, from the options, the second one will be the correct one. That is, they are not equal to each other, the Poisson ratio. The next question, that in a 0-degree 90-degree symmetric graphite epoxy laminate, what will be the value of the shear extension coupling? So as the shear stress in xy direction for a 090 laminate is equal to 0, so there won't be a shear extension coupling value with, and hence the option D is the correct one, which shows that the shear extension coupling value is equal to 0 for the 090, for the 0-degree laminate, also the 90-degree. Next question is, in a 0-degree or 90-degree symmetric graphite epoxy laminate, when subjected to axial load Nx, which of the following interlaminar stresses develop at the free edges? As we already saw in the previous question, that the shear stress in xy direction for a 090 laminate is equal to 0. And here to find the out of place stresses at the free edges, you can see that tau xz is the one which is dependent on the shear stress in xy direction. And as for 090 laminate, the shear stress in xy direction is equal to 0. So the shear stress in xz direction will also be 0. Whereas here you can see the stresses in y direction is non-zero for 0 and 90 degree laminas. So you will get from that we can see the shear stress in yz direction and the stress in z direction are dependent on the stresses in y direction. As these values are non-zero, so we will also get non-zero values of the stresses in yz and stress in z direction, shear stress in yz and stress in z direction. So the answer will be option C, that in a 0 degree and 90 degree symmetric graphite epoxy laminate, when subjected to axial load, the interlaminar stresses developed at the free edges will be sigma z and tau yz. So the next question is, in a plus 45 degree and minus 45 degree symmetric graphite epoxy laminate, when subjected to axial load Nx, which of the following interlaminar stresses will develop at the free edges? So, for as we did in the initial two questions, for plus minus 45 degree symmetric laminate, the conditions and the final stresses we will find will be such that the stress in x direction for plus and minus theta will be equal and not equal to 0, whereas in y direction it will be equal to 0, and the shear stress in xy direction for plus and minus theta will be equal but opposite in their signs. So from this data we can find what will be the outer plane stresses, and from the relation here you can see. So for a plus minus theta symmetric laminate, you can see the sigma y, that is the stress in y direction, is equal to 0, and the outer plane stresses sigma z and shear stress in yz direction are the two which are dependent on the stress in the y direction. As you can see, the stress in the y direction value is 0, so these two values will also be 0. So only outer plane stress we will get for a plus minus theta symmetric laminate will be the shear stress in xz direction. So the answer here will be B option, that is shear stress in xz direction only. Our next question is, interlaminar stresses at the interface of plus 45 degree and minus 45 degree lamina is developed due to. The first option says that there is a mismatch of Poisson ratio between plus 45 degree and minus 45 degree, which is not correct. As you already saw in the first question that they are equal, the Poisson ratio is equal. Second option says that there is a mismatch of coefficient of shear extension coupling between plus 45 degree and minus 45 lamina, which is the correct option. As you can see, we found that the shear extension coupling for plus theta and minus theta layers are equal but opposite to each other. That is, one is positive and other will be negative, which are going opposite directions. Because of that, it will cause stress in both the laminas, as both the laminas will have shear stress in moving opposite to each other, which will cause interlaminar stresses. So there is a mismatch of coefficient of shear extension coupling. So this is the reason because of which the stresses are developed between a positive and negative theta laminas. The next question is, in an n-layered laminate where xy represent in plane and z represent thickness direction, the interlaminar stresses responsible for delamination are. So this is directly from the theory that which are the different outer plane stresses which causes delamination in any laminate. So the answer is the stress in z direction and the shear stress in xz and yz, or which is symmetric to the shear stresses in zx and zy direction respectively. So this will be the answer. The next question is, a plus 30 degree and minus 30 degree symmetric graphite epoxy laminate when subjected to axial load Nx, then which of the following interlaminar stresses will be developed at the free edges? So for any plus minus theta symmetric laminate, this is the condition which we will find the stresses, the value of the stresses we will find in such a way that the stresses in the x direction will be non-zero and equal, whereas in y direction it will be zero, and the shear stress will be equal but opposite region. So this is either it is 45 degree or 30 degree. It is a plus minus theta laminate structure. So for that these conditions apply. So from these conditions you can see as the shear stress in y direction will be equal to 0. So we will, as there is no stress in the y direction which is equal to 0, so there will be no shear stress in yz direction and also no normal stress in z direction. So only shear stress, only stress, out of plane stress remains at the free edge will be the shear stress in xz direction. So the answer of this question will be B option, which is that we will get shear stress in xz direction only. And the next question is 0 degree plus minus theta degree and 90 degree symmetric graphite epoxy laminate when subjected to axial load Nx. Which of the following interlaminar stresses develop at the free edge at the interface of 0 degree and plus theta symmetry? Now this is a mixture of 0, 90 and angles. So when there are laminas in which has the direction of the fibers in all the direction, there will be stresses in all the direction when the whole laminate will be subjected to any axial load. So the final answer so there will be non-zero values of all the in-plane stresses, and because of that the out-plane stresses will also be non-zero values. So for this, the first option is the correct one, that all the values of the out-plane stresses will be non-zero. As they ask what will be the stress developed at 0 and the angle. As you can see, for an angle the stress in y direction will be 0, but for 0 degree the stress, there is a stress in y direction. Because of that, sigma yz and sigma z will be there, and also for a 0 degree laminate the shear stress in xy direction is non-zero, but there will be a value of shear stress in xy direction for an angle laminate. Because of that, there will be an outer plane stress in x z direction also. Hence, we will get the value of all the three outer plane stresses: sigma, uh, the shear stress in x z and y z direction, and also the normal stress in z direction. Okay. Thank you.